Next we'll see commutation relation between commutation relation between between L and L and X position. X, here I'm taking L and position, means I'm taking X there. See here, so what is L? Where L is nothing but orbital angular momentum. So where L can be written as L equal to R cross P, where R is position and P is momentum. Okay, so here I am writing this one as, so you know that L can be written as I Lx plus J Ly plus K Lz, and momentum P can also be written as I into Px plus J into Py plus K into Pz. Okay, so now take L cross, here I am taking, in place of R I am taking I into X plus J into Y plus K into Z. So now I'm substituting all these terms here, then we'll get I into Lx plus J into Ly plus K into Lz equal to, so R cross P can be I J K. Here in place of R I'm taking X Y Z, and here I'm taking Px Py and Pz. Okay, so now find the values, then we'll get their compare LHS and RHS terms, then we'll get their Lx value is ypz minus zpy, comma Ly value is what we get there, zpx minus xpz, and finally Lz value can be here xpy minus ypx. Okay, so we got Lx and Ly Lz values. Now let us see the different relations between angular momentum and position. Okay, so let us see first one, Lx comma x. The commutation between Lx means angular momentum along the x direction, and where it is x I am taking here the relation between them. Let us see how can we find this one. Okay, so already we know that what is Lx value. Lx value is ypz minus zpy. Okay, so comma, here I am taking x. Now let us separate the terms. I am writing this one as, see here, ypz comma x minus, I am writing this one as zpy comma x, separating the terms. So again I am writing this one as, here y comma x into, here I am writing pz. Okay, pz plus I am writing this one as ypz comma x, and minus, this can be written as z comma x py, and minus z into py comma x, separating the terms. Now the commutation relation between y comma x is what? 0, and remaining is 0, plus, and the commutation between pz comma x can also be 0. Okay, can also be 0, and minus, here the commutation between zx 0, and this one also 0. Here py comma x also 0, because they are different terms here. See the pz comma x, if it is px comma x we'll get ih cross, but they are different, so here also we'll get 0, and the final 0. That means the commutation between lx comma x is 0, and similarly the commutation between lx comma y, you have to find out the commutation between lx comma y. So what we get, the commutation rule between lx comma y, let us see what we get here. Lx comma y I am going to find out. Okay, so now what is lx value? Lx value is what? Y pz minus zpy comma y. Okay, lx comma y I am going to find out. Now separate the terms, see what we get if we separate the terms. Ypz comma y minus zpy comma y. Okay, now separate the terms. Here I am writing y into pz comma y plus y comma y into pz. Here I am writing this one as z into py comma y minus z comma y into py. Okay, so what is the commutation rule between pz and y? 0, because both are different, plus. And the commutation rule between two similar operators can be 0, similar variables. Here this can be minus z, and we know that py comma y. So that is what we get, minus ih cross. Okay, minus ih cross, and this is 0. So finally we'll get there ih cross z. Now that means what? The computation between lx comma ly, sorry, lx comma y, the computation between lx comma y can be, is how much? I h cross z. Okay, I h cross z. So similarly we'll get the different relations. If you practice, you'll get very easily the computation between lx comma z, lx comma z. What we get here? Minus ih cross y will get there. Okay, next the commutation between ly comma x, the commutation between ly comma x will get there, minus ih cross z will get there. Next commutation between ly comma y, the commutation between ly comma y is 0. Next the commutation between ly comma z can be, what we get there? Ih cross x will get there. Okay, next the commutation between lz comma x will get there, ih cross y. Next the commutation between lz comma y can be, what we get there? Minus ih cross x. Okay, next the commutation between lz comma z can be what? 0. So in this way we can get different values for the commutation rule, commutation between angular momentum and the position. The commutation between angular momentum L and linear momentum P. I'm going to find out the relation between them. Okay, let us see first one. Here I'm going to find out Lx comma Px. Lx comma Px. See, how can I find this? What is Lx? How can I write Lx? You know, just now we have seen Lx can be written as ypz minus zpy. Okay, so comma, here I am writing Px. Now the separate the terms, what we get? ypz comma Px minus zpy comma Px. So again write this one as here y pz comma Px plus y comma Px into Pz, and here I am writing minus z into py comma Px, and minus, here I am writing z comma Px into Py. Okay, now let us write the values where the relation computation between these two things is 0, and here different terms are there, y and x is there 0, and here py px 0, and here it is z px also 0. Then finally we'll get 0. That means the computation between lx and px, the computation between lx and px is 0. Now again we have to find out the computation between lx and py, the computation between lx and py. Okay, let us write here. So you know what is lx? Lx means what? P, so y pz minus z py comma py. See, how can I write this one? So separating the terms, y pz comma py minus z py comma py. Now separate the terms, y pz comma py, okay, plus y comma py into pz. Okay, so minus, here I am writing this one as z into py comma py minus z py into py. Okay, see, the value of this one is 0, first term, and this term you know that y comma py, ih cross, here pz remains same, and this is also 0, and here is different terms are there 0. So finally we have ih cross pz. Then the commutation between lx comma py is how much? ih cross pz. Okay, so finally let us see different relations, commutation relations between momentum and angular momentum can be written. See, let us write one by one here. The commutation between lx comma px can be 0, and lx comma py can be ih cross pz, and the commutation rule between lx comma pz can be minus ih cross py. Okay, next similarly ly comma px, can be minus ih cross pz. Okay, now the commutation between ly comma py is 0, and ly comma pz equal to ih cross px, and the commutation between lz comma px can be ih cross py, and lz comma py can be minus ih cross px, and lz comma tz can be 0. So in this way we will find different commutation relations between L and P.